These are the recorded lectures for Chapter 2, Part A. And this chapter is on chemistry. Why this matters is that understanding chemistry and biochemistry helps to determine the most effective solutions to use to treat dehydration and fluid loss. That's just one reason why this matters, but I'm going to add to that. A big reason why this matters is that this material from this chapter is going to be on your TEAS test, and many of you have to take that TEAS test for acceptance into the nursing program. As a lot of people take this class for that reason, so or into an allied health program. So because of that, we make sure we cover it. And another thing is that the other chapters are going to have some chemistry and biochemistry in them, just like randomly. So different chapters you need to know information from chapter 2. In other chapters, there's a lot of different examples. I mean, they gave you dehydration and fluid loss, which, would be found in the urinary system. We would deal with that during the urinary system and the cardiovascular system, which we don't get to until Bio 169. But, in all the systems, there's some knowledge of chemistry and biochemistry that you need. So anyway, it does matter for that reason. You need that that background information. And this video is on slide number 3, if you want to go back and watch it. This one is a career connection involving chemistry. Now we're going to move on to the notes. Chemistry and physiological reactions. We're going to divide chemistry into basic chemistry and biochemistry. Biochemistry will deal with organic chemistry, the chemistry of molecules that are larger and they are composed of carbon and hydrogen. And also the large molecules, proteins, carbohydrates, lipids, and nucleic acids, the 4 biomolecules or macromolecules as they're called. So we'll do basic chemistry first, which is this part 1, basic chemistry, which is what part A deals with. And then when we get to part B, the recordings with chapter 2 part B, that will be focusing on the biochemistry. So basic chemistry starts with section 2.1, which focuses on matter and energy. You should have at some point in your life, even if it was elementary school science, heard these terms before, learned these terms. Matter is anything that has mass and occupies space. So chemicals are examples of matter. All the different chemicals and their state, whether it be solid, liquid, or gas, are examples of matter. So anything that has mass or weight and occupies space or volume. Matter can be seen, smelled, and or felt, or measured in some way. So even if it's a gas that can't be smelled and can't be seen, if it's a colorless, odorless gas, we can weigh it. You have to have it in a container to weigh it, but you can weigh it, So weight is defined as mass plus the effects of gravity. So mass would be like in grams or kilograms or milligrams, whereas weight would be, in pounds. But the difference is that weight takes gravity into account. Your weight is different on the moon than what it is on Earth, but mass is the same in both places. The states of matter are solid, liquid, and gas, and there is also a 4th state of matter called plasma, which is found in stars, like the sun. But on the Earth, we just focus on solid, liquid, and gas. Solid matter has a definite shape and volume. Liquid has a changeable shape that changes shape with the container that it's in, but a definite volume. And gas has a changeable shape and volume. Gas expands to fit the container that it's in. Energy is defined as the capacity to do work or put matter into motion. Energy does not have mass, nor does it take up space. The greater the work done, the more energy it uses up. So when we study energy and as far as chemistry is concerned, and by the way, this video is on slide 9. If you want to look it up in the PowerPoints that are posted on Moodle, this video is on energy concepts. So this is slide 9. But when we study energy in terms of whether it's kinetic or potential. If energy is kinetic, it's the energy of action or motion. If it's potential, it is stored energy that's inactive. In chemistry, potential energy is stored in chemical bonds, and kinetic energy is when those bonds are broken. It's released when those bonds are broken. So energy can be transformed from potential to kinetic energy, like I just said, in chemicals, in different chemical compounds. The energy is stored in the bonds between the atoms. But then when those bonds are broken during a chemical reaction, kinetic energy is released. And chemical energy, which is stored in the bonds of chemical substances called compounds or molecules, is potential energy. But there's other forms of energy. There's electrical energy, which we will talk about when we learn about muscle contractions and nerve impulses. Electrical energy results from the movement of charged particles. So that happens in our body, and it happens during the transmission of nerve impulses. And so we will get into that in the muscle and nerve chapters. Mechanical energy is directly involved in moving matter. So there's mechanical energy that we we'll have various examples, but it'll be electrical energy converted to mechanical energy whenever you talk about like say walking. When humans walk or swim or move their body in any way, the movement is the mechanical energy, but the electrical impulses and the muscle contractions that lead to that movement are electrical. Okay, so then there's also radiant or electromagnetic energy that travels in waves. So heat that is released from our body, given off to the atmosphere, is radiant or electromagnetic energy. We have visible light, we have ultraviolet light from the sun, and then we have X-rays and other forms of radiation, maybe that are used in, radiation therapy, that kind of thing. So energy form conversions. Energy may be converted from one form to another. For example, when you turn on a lamp, that converts electrical energy into light energy. And we just talked about energy conversion, electrical energy from the signals sent from your nerves to your muscles, the electrical energy involved in generating a muscle contraction, that is converted to mechanical energy of movement, So energy forms can be converted. Energy conversion is inefficient. Some energy is always lost as heat. It's not really lost, but you can't use it anymore. That heat gets sent to the atmosphere, and we can't actually use it. So that's why we say it's lost. It's really not lost. It's just not usable anymore. All right, section 2, atoms and elements. All matter is composed of elements. The elements are found on the periodic table of elements. Elements are defined as substances that cannot be broken down into simpler substances by ordinary chemical methods. So they're the simplest substances that exist. There are 4 elements you need to know because they make up 96% of our body, of the human body. And they are carbon. The symbol for carbon is a capital C. Oxygen, capital O, hydrogen, capital H, and nitrogen, capital N. So know the names and the symbols for those 4 elements. There are 9 elements that make up 3.9% of the body, which is the rest of almost the other 4%, besides carbon, oxygen, hydrogen, and nitrogen. And there are 11 that make up less than 0.01%. The periodic table lists all the known elements, but we don't have to learn the whole periodic table in any of our biology classes, including this one. We just really need to know chemistry that applies to what we are learning, what we are doing. So the simplest form of an element is an atom. All elements are made up of atoms. Atom is just the smallest unit of an element that has the properties of that element. So atoms are unique building blocks for each element. They're the smallest particles of an element with properties of that element. And what gives each element is particular physical and chemical properties. So for example, if we go back and talk about our carbon, carbon's going to be really, really important. An atom of carbon is just the smallest particle of carbon that exists. The element carbon can have many atoms of carbon, okay? So, and it's the same way for all the other elements. An atom is the smallest particle of that element that can exist. The atomic symbol is either 1 or 2 letters, and it's a kind of like chemical shorthand for each element. So I just told you that the symbol for oxygen is a capital O, carbon is a capital C. Some of the symbols come from the Latin names. The Latin name for sodium is natrium, and so the symbol is capital N, lowercase a. The Latin name for potassium is kalium, so the symbol is capital K, just a K. And those are important because we definitely deal with sodium and potassium ions in Bio 168 and Bio 169 for sure. So this table shows you the 4 elements that make up 96% of the body. Oxygen makes up 65%, carbon is 18.5, hydrogen is 9.5, nitrogen is 3.2. And it tells you where you find these, like for example, nitrogen is a component of proteins and nucleic acids like DNA. And then carbon, oxygen, and hydrogen are components of really all the chemicals that make up the body structure. Now, this table is the elements that make up the 3.9%. Calcium, phosphorus, potassium, and then it tells you the functions of those elements, where you find them. Of course, calcium is found in bones and teeth, but it's also found in its ionic form. Calcium with a +2 charge is found dissolved in our blood, and it's required for muscle contraction and conducting nerve impulses, as well as blood clotting. So calcium is important in compounds that form substances like bone and teeth, but it's also important as an ion, what we call an electrolyte, in carrying out some of our body's physiological functions. Then we have phosphorus, potassium, sulfur, sodium, chlorine, magnesium, iodine. Iodine is real important in making thyroid hormones. And iron, which is Fe. And iron is an important component of hemoglobin, so it's necessary for transporting oxygen. Then we have, you don't need to learn these or anything, but this is the trace elements that we need in small amounts for various functions in our body, and they make up less than 0.01% of our body composition, and that's chromium, cobalt, copper, fluorine, manganese, molybdenum, selenium, silicon, tin, vanadium, and zinc. So these are all metals, well, except fluorine. Well, yeah, they're all metals except fluorine. The rest of them are metals of some description. Okay, so they're trace elements that are required in minute amounts. Now, moving back to the topic of atoms, atoms have particles. They're called subatomic particles. There are 3 that you need to know, and what you need to know about them is their charge and their location within the atom. So protons have a positive charge, and they're located in the nucleus. Neutrons have no charge. They are neutral. and they're located in the nucleus.